So we left off with the graph. So we did the table. And then we figured out, last thing we did was figure out where it's increasing, decreasing, right? We used where the derivative was positive, it's increasing. Where the derivative was negative, it's decreasing. Okay. All right, so now it's the same graph. This is the same, it's the same graph. So that's why I put the table up there. So I'm gonna fill out the table the way we did on the first page. I just put the table there because we were referring to it. So instead of having to go back and forth, -3, -5.5. Okay. It's the same table, same graph. Okay. So now they want to know where is G concave up or concave down. Okay. Where is G? So what does G refer to? So when we talk about G, what does that refer to? Not the derivative. Okay, which original? You got to be more specific. Original what? We have this guy, and this guy. Okay? So G is the area under the curve. That's what this means. Area under the curve, right? Talked about it last chapter. So G refers to the area under the curve. That's how we made the table, right? G's derivative, we talked about this yesterday, is the graph. So that's how we answered increasing, decreasing. Okay? So now, concave up and concave down refers to G double prime. Positive, negative. Because that's what we said. Okay. Okay, so now where is this, what or where is the second derivative of G? If the first derivative is the graph, what or where is the second derivative? The slopes of the graph, right? So let me write this down. I didn't write it down earlier. So G prime refers to the graph. G double prime refers to the derivatives of the graph. The slopes, right? Slopes. Derivatives of graphs are just slopes. Okay? So we have to figure out where the slopes of the graph are positive and where the slopes of the graph are negative. Okay? Okay. So let's write this down. Concave up, concave down. Okay. Okay. How do we know if a slope is positive or a slope is negative? What tells us if a slope is positive or a slope is negative? Increasing, decreasing, up, down, rising, falling, however you want to think about it, right? So if a slope is increasing, it's going uphill. So let's see. Well, it's going downhill right now. Then it changes course. And then it changes course back again. So it looks like this guy was only increasing from -1 to 0, from the interval -1 to 0. Okay, so let's write that down. From -1 to 0. And then we have to justify, because it always asks us to justify. Because G double prime is positive. You don't have to explain the slopes are rising, the slopes are increasing. No, just say the second derivative is positive. Okay, so the yellow is where it was decreasing. From -3 to -1, and from 0 to 3. And that's because G double prime was negative. Okay. One of the hardest things to do in this class is to look at a graph and be able to tell those things, because there's a lot in the graph, right? When you guys in Math 1, Math 2, Math 3, when you look at a graph, you're really only looking at the graph. You're looking at points, right? You're only looking at points. In this class, there's layers to this graph. Are we looking at the area under the curve? That's one layer. Are we looking at just the graph? That's another layer. Are we looking at the slopes of this graph? That's another layer. Are we looking at concave or concave up or concave down? That's another. There's 4 layers to this graph. So being able to know what layers are which is hard. It's not easy, but it takes practice. It takes practice. That's all it does. Okay? Okay, so now we got to figure out maximum, minimum, relative maximum, minimum, and then justify your response. Okay? So let's go back. Relative maximum, minimum are where the first derivative switches signs. So we're looking for where the first derivative switches signs. First derivative switches signs. Okay. Again, there are 4 layers to this graph. Which one of them will be the first derivative? What do I look for when I'm looking for the first derivative? When I say first derivative of G prime, how do I look at this graph? What am I looking for exactly? We did it for increasing, decreasing, so we've seen it before. We've seen it through this lens. We just got to remember from yesterday. Mm-hmm. So we're going to look at the graph, right? But again, there's 4 layers to the graph. There's area under the curve. Are we looking at that? Are we looking at just the graph, the y values? Are we looking at the slopes of the graph? Are we looking at the concave up, concave down? Which layer are we looking at? So we're definitely looking at the graph, the y values. There you go. If G is the area under the curve, right? Let me write this down. Write this. If G is area under the curve, so G refers to area under the curve. G prime is going to refer to the y values. G double prime is going to refer to the slopes. G triple prime is going to refer to concave up or down. So since we're looking for relative maximum and minimums, that's G prime. G prime means y values. So we want to know where the y values switch signs. So where do the y values switch signs? What point or points? Where at? So where do these guys switch signs? -2, it looks like it crosses over from the positives to the negatives. Anywhere else? Does it switch sign? I was going to say 0. Does it switch signs at 0? What is it before 0? Negative. And what is it after 0? Negative. So is that a critical point? Yes. So if they said what is a critical point, I would say absolutely. But it's not going to be a relative maximum minimum because it doesn't switch signs. Yeah. Why does not switch signs? Y does not switch signs there. So the only one we have is -2. Okay. Here's the question. Is it a maximum or is it a minimum at -2? So it switches signs from, minimum said it switches signs from negative to positive. Did the y value switch from negative to positive at -2? It's actually the opposite, right? It switches from positive to negative. Positive y values to negative y values, right? Positive up here, then switches down to negative. Okay. So that's going to be a maximum. So we have a maximum at relative maximum at x equals -2 because g prime switches from positive to negative. Done. Okay. Is there going to be a relative minimum? No. So we would say no relative minimum. Okay. Last thing is inflection points. Inflection points. Okay, so let's go back to our cheat sheet. Inflection points are where the second derivative switches signs. The second derivative. So the second derivative refers to slopes. Slopes of the graph. Let me erase all this. Okay, so where do the slopes of the graph switch signs? Where do the slopes, where does it change from a positive slope to a negative slope or a negative slope to a positive slope? Yeah, -1 switches from negative slope to positive slope, right? -1 is I would say definitely. Anywhere else? 0, yeah. This time 0, because definitely switches. So we have 2 points of inflection. 2 points of inflection. -1 and 0. So we would say points of inflection at -1, 0. Because, let's go back to our cheat sheet. Because f, or in this case g double prime switches signs. You don't have to get specific. You don't have to say the slopes of G prime or G double prime or you don't have to do that. Just very generic. That's why the cheat sheet helps. The cheat sheet helps because it gives you your so if I was taking this test for the first time and I had a problem like that, I'd have on my cheat sheet on my card, I'd have two things. I'd have all of my justifications. These are all your justifications, right? That's important. Because if it's a 3-point question, you're going to get 1 point for the justification. You could do the problem right, but if you don't have the correct justification, you're only going to get 2 out of 3. The other thing I would have is where to look on the graph. Where to look on the graph. Okay? Kind of like this up here. Where do I look? If I'm referring to G, what does that mean? Well, G is all the area under the curve. If I'm referring to G prime, what does that mean? That's the y values of the graph. If I'm referring to G double prime, that's the slopes. Kind of a guide through how to solve the problem. One cheat sheet on how to solve the problem. The other cheat sheet on justifications. Okay? All right. Because a lot of this, like I said, a lot of it, I don't want to say you don't want to memorize, but it's tough to memorize because it's a lot of different stuff. So it's just easy to throw them on a little card and say, that's it. You don't have to memorize it. Okay? Okay. Eventually, when you do it enough, you will end up memorizing it. But for right now, like I said, just that's what I would do. Put it on a card. Okay, so the last thing is graph of F, or G, graph of G. G refers to the area under the curve, right? Which we created a table for. Go make dots. Let's go make dots. -3, 0. -2, +1. -1, 0. 0, -1. 1, -1.5. 2, -3. 3, -5.5. There you go. Okay. So that's a graph of the areas. So you can see that from the interval -3 to +3, the overall maximum is at -2. What is that maximum? 1. And then the minimum is at 3, which is -5.5. Okay. All right, so the next page is a problem very similar. The only difference is instead of G, they use F. And instead of G, they use capital F. Sometimes they'll use capital F. Capital F means area under the curve. That's what capital F means. Okay, so they just kind of change the letters up, but it's essentially the same thing. Okay, so capital F refers to, on this guy, capital F refers to area under the curve. Lowercase f refers to the y values. F prime refers to the slopes. F double prime refers to concave up, concave down. Okay, they change up the lettering like that. It's the same, but it's the same thing. Sometimes they'll capitalize the area under the curve. Sometimes they won't. Sometimes they'll call it G. Okay. All right, so let's do this. Let's do these problems. So find the following. Capital F of 0. How do we find capital F of 0? Yeah, why 0? So what are we referring to? When we say capital F of 0, how do we get that number? You're right. 0 is the correct answer. How did you get that? It's area under the curve, right? It's area under the curve. So you plug it in. You're 0 to 0 for f of t, right? You plug it in for x. They plugged in 0 for x, so you plug in 0 up here. Area from, if the bounds are the same, area is just going to always be 0. Okay? F of 2. I'll do a couple of these with you guys, and then I'll let you guys do the rest. Okay? Okay, so f of 2. Well, since I plugged in 0 for x, I'm going to plug in 2 for x. 0 to 2. Okay? So 0 to 2. Oops. This area here looks like half of the circle, a quarter of a circle. So if area of a circle is pi r squared, and I only want a quarter of the circle, divided by 4. So it looks like area, it looks like radius is 2 here. So 2 squared is 4, pi over 4, you get pi. Okay. All right, so what I want you to do is do up to h. If you can do I, go for it, but go up to h. Figure out what those areas are. So f, capital F prime, is the derivative of f. It's y values. So I is asking for the y value. The y value of what? At -4. So I go to -4, make a dot. That y value is 0. Two, f prime, y value. At 2, the y value is 2. F prime of 6, the y value is -2. At 5, the y value looks like it's -1. Okay. Now they're asking about double prime. Slopes. What is the slope at that point? What is the slope of the tangent line at 2? So let's go find 2. What is the slope of the tangent line at that red dot? What is the slope of the tangent line at this red dot? What is the slope of the tangent line at this red dot? What is the slope of the tangent line at this red dot? The answer is, I'm not going to tell you. The reason is, we've been doing it since September. Slope of the tangent line. Slope of the tangent line. That we've been doing since September. One of them doesn't exist, I'll tell you that. One of them doesn't exist. One of M, N, O, or P, one of them is a DNE. Which one is a DNE? 2, 5, negative, half, or 0? Which one of those red dots can I not find a slope of the tangent line?
0.
Why 0?
Because it's in between like two slopes, so that's what can make it DNE.
It's a corner. Yeah, it's a corner. So if it's a corner, can't tell slope. What is the slope at 2? What is the slope at 5? How do I tell slope? Rise over run, right? 7th grade. Rise over run. So what's the rise over run here? Go down 2, over 2. Negative 2 over 2 is negative 1. Same thing over here for negative a half. I go down 2 over 1. Negative 2 over 1 is negative 2. What about 0? Or sorry, 2. I still haven't done 2 yet. What's the slope of the tangent line at 2? What would the tangent line look like at that dot on top of the circle? On top of the half circle, I should say. Be horizontal, right? Look like that. And what is the slope of any horizontal line? 0. Okay. All right. Last part. Still referring to the graph. So now we see the questions we've seen before. Increasing, decreasing, absolute max minimum, concave up, concave down, inflection points, all that good stuff. How do we know when F, capital F, is increasing and decreasing? What are we looking for? What are we looking for if capital F of D is increasing or decreasing? Exactly. We're looking at the derivative of capital F prime, which is the y values. Where are the y values positive and where are the y values negative? Okay, so let's go to this. Let's go to here. Okay, so negative here, positive here, negative here. Okay, so let's write this down. Increasing. Decreasing. Where are the y values negative? Where are the y values positive? Negative, decreasing, positive, increasing. -4 to like, it looks like -2.5. +4 to 6, decreasing. Because F, capital F prime, is negative. Increasing. Looks like from -2.5 to 0, and then 0 to 4. Okay. All right. Absolute maximum and minimum. We did that on our last problem. Yes, we did it on our last problem. Or I asked you on the last. I don't think we did it, but I asked you. How did we find the absolute maximum and minimums? What did we need to find the absolute maximum and minimums? I don't think I asked you that question, but I referred to it a couple times when I said absolute maximum and minimums. Okay, the y values. But how do I? Because when we looked at the last one, I said, oh, this is the absolute max and this is the absolute minimum. Exactly. But what do I need to be able to see it? A table, right? A table. That's what you got to make. Make a table. We got to make a table. We got to make a table of x values and the graph. Luckily, we have a lot of these values already because that's what we did for A through P. So it goes from -4 to 6, right? -4 to 6. Okay. F of -4. Did we do f of -4? Yes, -2. F of -3. -3. F of -2. -3 as well. F of -1. -1. F of 0. 0. F of 1. Do we do f of 1? Okay, we'll skip that one. We'll do it in a second. Let me just fill out the ones that we have done. Pi. 3. We didn't do 3 either. 4 we did. 2 pi. And then 6 we did. 2 pi minus 2. Now, there's a quicker way to do this. Do you have to make a complete table? It's tedious. It's time consuming, especially when you got a time crunch. There's a quicker way to do this. I'm getting to it in a second. So 1, f of 1. That kind of makes a weird shape. It's kind of like a rounded trapezoid, right? I don't know what shape that is, so I can't find the area, right? Okay. Same thing with 3, right? 3 kind of makes a rounded trapezoid too. Maybe that's why they didn't ask us to find those. 5, I can't. 5, I can't. So it would be the half 0 to 5 would be this plus this. Or, yeah, so it would be area from 0 to 4 was 2 pi, and then it would be minus half. So 2 pi minus half. Oops. Two pi minus 1/2. Okay. All right. So where is the highest? Where's the max? Where is the biggest value that we have so far? 2 pi, right? Because 4 is 2 pi. Then after 5 and 6, we start subtracting. That's so it looks like 4 is the biggest. Where's the lowest? Yeah, it looks like in between there, right? Okay. So let's start with the green. Is there something going on between -3 and -2 that we've seen before? What's going on at between -2 and -3 on the graph? Go look at -2 and -3 on the graph. What's happening at between -2 and -3 on the graph? Mm-hmm. The y values change signs. What's another word for that? No. What's another word for this guy changing signs? Yeah, how do I say this? When f prime changes signs, that refers to a critical point, critical value, right? So to find, and then what was the other one we found? We found at 4, right? Is 4 the same situation as -2.5? No?
No.
4 is a different situation? How is it a different situation?
Like, no, it's not.
So no, it's not a different situation.
No.
It's the same situation. I'm confused. Is it different than -2.5 or is it the same as -2.5? Opposite direction, right? But it still crosses, right? So in other words, you guys are saying it's a critical point, but not a maximum. It's different, right? So that's how we find, so let's write this down. Absolute maximum minimums, critical points, values, and then start/end of the interval. Those are the guys we got to check. We got to check that guy, and we got to check that guy. So we don't actually need a whole big table. We just need to check any critical points and the beginning and the end of the interval. Okay. So instead of having to check all of these points, all we needed to check was negative 2.5, or sorry, all we needed to check was negative 4, because that's the start of the interval, positive 6, because that's the end of the interval, negative 2.5, because that was a critical point, and 4, because that was a critical point. So we didn't need to check any of these guys over here. Or this guy. So the ones that we didn't know the answers to, didn't matter. So instead of checking both of those guys, I should have just checked negative 2.5. And then negative 2.5, did I do that one? I didn't do that one. I think, let's see, to find the area at negative 2.5, negative something, right? Let's see, negative 1.5, and then the height is 2. So negative 1.5 times 2 divided by 2, you would get negative 1.5. Wait, no, but that wouldn't be the... Should be negative 3.5. Sorry, I went the wrong direction. If I plugged in negative 3.5, I'm sorry, here, if I find the area of that guy, I'd have to switch the bounds. And then I would find the area from here to here. So that trapezoid would be negative 2.5, or sorry, negative 3.5. It'd be 3.5, but then I'd have to change it to negative because I flipped the bounds. Okay. All right, so let's write this down, and then we'll finish the rest. We'll finish up the last part next week. Okay, so absolute max at 4, x equals 4. No, actually, let's write it differently. F of 4, because we want to write the value, 2 pi. Absolute minimum at capital F, negative 2.5, which was negative 3.5. Because don't have any room here, but I would put because those are the highest and lowest y values. Those are the highest and lowest y values. Because 2 pi is the highest y value, negative 3.5 is the lowest y value. Okay. Okay, we'll finish the last two on Tuesday. It's going to take us about 5 minutes to finish up those. The rest of the time I'll give you to practice. So the practice I'm going to give you, there's going to be one of these guys, and then they're going to ask you different questions. That's what it's going to look like. Where is the relative maximum minimum? Where is the absolute maximum minimum? Where is it increasing? Where is it decreasing? Where is it concave up? Where is it concave down? Things like that. Okay, so I'll give you some time to practice on your own. Okay.